Hey everyone, and welcome. Today we are going to pull back the curtain on Arduino. It's this tiny little board, a real powerhouse that can bring your wildest ideas to life. Seriously, forget all that complex engineering stuff. Just think of it as a blank canvas for you, the inventor. So let's just jump right in with a big question.
And yeah, that's a totally fair question, right? How can something that fits in your hand be the brain behind a smart machine, maybe an obstacle-avoiding robot? It sounds kind of complicated, but I promise you, the answer is so much simpler and, honestly, way more fun than you think.
Okay, so here's the easiest way to wrap your head around it. The Arduino board, that's the brain. But, a brain on its own can't do much. It needs a way to understand the world around it and a way to do things in it. So we're gonna give our little brains some senses and some muscles.
First things first, the senses. In the Arduino world, we call these sensors. And all they do is take real-world stuff, like how bright a room is, or how far away an object is, and turn it into an electrical signal that the Arduino brain can actually understand. It's literally how our projects see, hear, and feel the world.
Now for the Arduino to make sense of these signals, it has to, well, speak the language. And the good news is there are really only two languages you need to know: digital and analog. That's it.
The difference is actually super simple. A digital signal is just like a regular light switch. It's either all the way on or it's all the way off. Like a push button. You press it or you don't. But an analog signal, that's more like a dimmer switch. It can be off, it can be fully on, or it can be anywhere in between. It gives us a whole range of information. This is how a light sensor tells us how dark it is, not just if it's dark. See the difference?
All right, so our project can now sense what's going on around it. Cool, but what's next? Well, we need to give it a way to react, to do something. It is time to give our Arduino some muscles.
These muscles are what we call actuators. They're the things that take the brain's commands and turn them into actual physical actions. So a simple buzzer can make some noise for an alarm. A servo motor can give us really precise controlled movement. And a DC motor, that gives us that continuous spinning motion, just like the wheels on a robot.
And let's talk about that servo motor for a second. Its superpower is its precision. It can move to any specific angle within a 180-degree arc and just hold that position, rock solid. That kind of accuracy is exactly what you need for things like robotic arms or those cool scanning radars.
Okay, but what about that DC motor? It's great at spinning, right? But what if we need our robot to back up? That's where this little genius circuit called an H-bridge comes in. You don't have to worry about the electronics inside. Just know this. It's the magic trick that lets our motors spin both forwards and backwards. It's what gives our robot reverse gear.
So, let's recap. We've got the senses to perceive the world, and we've got the muscles to act on it. Now we get to the really fun part, putting it all together. This is where a pile of parts actually becomes a smart, responsive project.
Okay, let's build something. We'll start with a simple sense. We're going to use a sensor to measure how much light is in the room.
And what's our action going to be? When it gets dark, what do we want to happen? Let's do the simplest thing possible. We'll have the Arduino turn on a little light, an LED. And boom, just like that, by connecting that one sense to that one action, we've built a smart night lamp. When the room gets dark, the light pops on. So simple, but so cool.
Let's try another one. This time our sense is going to be distance. We'll use what's called an ultrasonic sensor. It kind of works like a bat's sonar. It sends out a little sound wave and measures how long it takes to bounce back.
And for our action, let's grab one of those muscles we talked about, the buzzer. We can tell the Arduino to make a sound if something gets too close.
You put those two together, and what do you have? A distance alarm. It's basically the same technology as the parking sensors in a car. The closer you get to the wall, the faster it beeps. See? It's just simple building blocks.
Now let's get clever. We're going to take that exact same distance sensor. We don't need new parts for a more complex project. We just need a new idea. So we're still just sensing distance.
But this time, for our action, what if we mount that sensor on our super precise servo motor? Now, instead of just staring straight ahead, we can make it sweep back and forth, scanning the whole area. And what does that give you? A scanning radar system. By combining the exact same sensor with a different kind of muscle, we've leveled up from a simple beeper to a project that can actually map its surroundings. It's all about those creative combinations. So you see the pattern here, right? We have the building blocks, the senses and the muscles, and we have the logic that connects them. That same pattern applies to every single project, no matter how big or small. Which means, guess what? You're ready to start building.
And before you start, here's probably the single most useful tip I can give you. Things are gonna go wrong. Your code won't work the first time, and that is totally okay. Using something called the serial monitor to print out your sensor values lets you peek inside the Arduino's brain to see what it's thinking. It makes finding and squashing bugs so much easier.
And as you get going, just try to keep these simple habits in mind. Leave comments in your code so you remember what you were thinking. Give your parts clear names, not just sensor 1 and sensor 2. And try to keep your code organized in small, simple chunks. Trust me on this, your future self will thank you.
So there you have it. We've broken it all down. You've met the sensors that feel, the actuators that move, and the simple logic that connects them all together. You now have all the fundamental pieces of the puzzle. The only real question left is, what are you going to create first?